Good morning, everyone. It is Thursday, August 5th, and you have just over 48 hours to complete your last exam, exam number 4. You're going to be given 80 minutes for 60 questions on the immune system, the renal system, and the GI system. I want to emphasize that I am not going to be able to give any makeup exams, any late exams. So please take it by the deadline, by Saturday evening. Once again, it is due Saturday evening and not Sunday evening. And I will hold office hours on Sunday at noon in the event any of you want to go over your exam prior to me inputting my grades for the summer term. One thing to think about when we're looking at all of the transport of ions and molecules across these cells, whether they are in the duodenum, in the stomach, in the ileum, somewhere in the small intestine, is I've talked about pumps and I've talked about co-transporters. So when we look here at the parietal cell, we have the hydrogen potassium pump, otherwise known as the hydrogen potassium ATPase. The goal here is to move hydrogen into the lumen of the stomach, and this would be the lumen right here. And what I suggested in the video for this is the stomach lumen has a very, very low pH, around 0.8, which means there's a super high concentration, and I apologize, I think I said sodium. The lumen of the stomach has a very low pH, a very high concentration of hydrogen ions, which means there's going to be a higher concentration of hydrogen ions in the stomach lumen than within the parietal cell. So to move the hydrogen ions from inside the cell to the lumen is moving hydrogen ions against their gradients. Now, what about potassium? Potassium is coming in this pump. And we always know, we've talked about this from the very first day of class, that potassium has a higher concentration in cells than outside of cells, which means potassium too is moving against its gradient into the cell. That allows us to remember or figure out that this is an ATPase or a pump rather than a co-transporter. And a co-transporter, something like we see in the duodenum or in the pancreas, it's utilizing the kinetic energy of one of the ions transported down their gradient to pump the other one against their gradient. And that's what we see right here in the sodium hydrogen co-transporter or symporter, or antiporter, because they're going in opposite directions. Sodium is moving into the cell down its gradient, because since the first day of class we've always suggested there's a much lower concentration of sodium inside of cells than outside of the cells. Moving down its gradient is going to create kinetic energy, and that energy is going to be utilized to pump hydrogen out of the cell against its gradient. Okay, office hours today at 3 o'clock.